Alright, here we go. So, I'm going to go through a lot of notes with you. It's because most of you have taken physics, so it kind of drags on if I try to make this a big ordeal. We're going to go through analyzing particle motion algebraically today, and then we'll move on to graphically. So to start off, not that stuff, we're going to start off by using just what we learned from yesterday. I want you to give me the units of the derivatives of the graph that you have there. So I gave you the units. I want the units of the derivative. So someone want to explain to me how to find the units of the derivative given all I have are units themselves. Jason, what are you doing down on your paper? What do you remember from yesterday? Good. dy over dx. Good. Your feet would be your y's. Your x's will be your minutes. So I'm going to take this and I'm going to add in a few things. First of all, if you see feet, you're probably measuring position. Position or distance. And when we start talking about the position function, oddly enough, it's not p of t. They always use s. I actually don't know why, though. S sub t. So, given what you have, I really could have taken this and said ds dt is feet per minute. Well, feet per minute, where have you seen feet per minute? If you've taken physics, where have you seen feet per minute? What does that measure? Velocity. Yeah, it measures velocity, which is also known as v of t. Therefore, for this one, if we do exactly what Jason told us, I'm going to write it with notation dv dt. I would get feet per minute, but divided by minute again, which does simplify to feet per minute squared, which Isaac might have been what you were thinking about, which is acceleration. So this measures acceleration. Feet per minute squared. Knowing your units will help you through a lot of things, okay? So that's just your units. Now that we've seen that, I'm going to go through a lot of notes. Let's start out with position. So not only will you see s sub t, I may decide to do x of t, or I may decide to say y of t. You see those because sometimes I'll say that the function's moving along the x-axis, or the function's moving along the y-axis, or things like that. Displacement. So let's see what you guys know about displacement. I'm going to stand in the middle of the room, and this is 0. Okay? I move 5 steps to the right. 1, 2, 3, 4, 5. What is my displacement? 5. Okay. Going back to the middle, I walk 5 steps to the left. 1, 2, 3, 4, 5. What is my displacement? So, thumbs up for 5. How many do I have for 5? Okay. I think, -5. How many do I have for -5? Got a few. Okay. All right, let's hold off on that for a second. I'm not going to say which one's right. I am here, back at 0. I walk 3 steps to the right, and I also walk 3 steps back. What is my displacement? 0. Okay, so 0 we got, the +5 we got, but going backwards we had 2 different answers, positive and -5. So let's see if we can answer that question by a formula. So displacement actually is a formula. It is, and I'll explain the formula, S sub b minus S sub a. So first of all, what are all these crazy letters? S stands for what? Which function? Position. A is a starting time. B is your final time. If I was using physics terms, initial, final. So this says take your final position minus your initial position. So let's go back. I am starting at 0. I walk 1, 2, 3, 4, 5 steps to the left. This is my ending position. using the formula, let's try it. My position walking back to here, which is my ending position, is what value? I walked backwards from 0. Really, people? I walked backwards from 0. What number would I be standing on? -5 minus my initial position, which was here. How much was I at? 0. So what is my displacement when I walk 5 backwards? -5. Why? Because displacement does have positives and negatives. That's probably your confusion, usually the confusion. Displacement, if it's negative, what does it mean? It means from wherever I started, I am to the left or backwards from it. Positive displacement, from where I started, I'm to the right. So displacement's kind of interesting because I can do all kinds of crazy things. I'm starting at 0. I'm going to walk to the right 3. I'm going to walk backwards 5. I'm going to walk back again 2. I'm going to walk back again 5. I'm going to walk forward 5. I'm right back at 0. My displacement was 0. All you care about is the ending position and your beginning position. I don't care what happens in between. You can do a crazy dance in between. But it doesn't matter, ending versus beginning. That's all you need. All right? To find the displacement, which function are we going to use? The position. Because we're going to start talking about a lot of functions today. All right? So, next piece. Look at all those notes. Woo! All right. Velocity. We just learned that in the beginning of the section, we did our little, I think, units. We figured out that velocity is a derivative of position. Hopefully you're saying position and displacement are different. Okay? Position is where you're at. Displacement is how much you have moved. Okay? V of t, so notation-wise, we could either write it as s prime, or we can write it as ds dt. Those are the two ways. I'm actually going to come over here to the right where it says instantaneous velocity because people get confused with this. You notice how I just said velocity here? If I just say the word velocity, it always is instantaneous. They are the same thing. So instantaneous velocity is exactly the same thing as the derivative of position. Okay? They're the same. So if I just say find the velocity at 5, I want the derivative of position at 5. But if I say average velocity, this word changes what you're doing. When we did average rate of change, what did we have to do? y2 minus y1 over x2 minus x1. And we're actually going to keep with that. So, if I'm doing a velocity, it comes from a rate of change. Whose slope or whose rate of change am I finding to get velocity? Where did we come from? Hello? On the board. Just read it. Position. All right. So we came from position because position's derivative gives us velocity, while position's slope gives us average velocity. So when you see the word average velocity, everyone gets it wrong. It is actually the change in position, which would be the displacement on top, divided by the change in your x's. Well, x's now are time. Time b and time a. Here's what most people do as their mistake, and they keep getting it wrong. V of b minus v of a all over b minus a. Notice when you take velocity, you need the position function to be able to get it. Okay, that's where it comes from. All right, so what can velocity tell us? Velocity tells us two things. It tells us how fast you're going and what direction. That thing in your car that tells you how fast you're going, what's it called? A speedometer. Why don't they call it a velocity meter or velocimeter? It doesn't give you direction. Why? Are you sure? Are you just saying that? I feel like you're just saying that. I feel like you made an unfounded statement. Prove it. Prove it. No proof? You keep saying it doesn't tell me direction. Prove it. Why not? It's not a trick question. It's actually a really simple answer. Have you ever gone backwards in your car? Reversed? Does the thing go to the negatives? No, that's the proof. That's what I needed. You're like, I don't have proof. Stop looking at me. That's the proof. If you went backwards in your car and you're going backwards 5 miles per hour, it's still going to say positive 5 miles per hour. So that's why we do a speedometer in the car. So, given that information, feel like you'll be able to go through this with me. So, if your velocity is positive, I'm moving at positive 20 miles per hour. What it tells you is not only how fast you're going, but what direction you're going. And what direction am I going? I am moving forward. If we're talking about up and down, then you're moving up. Therefore, now that you know that, velocity negative, moving backwards. Which, if we're talking about up and down, that would be the down motion. Velocity is 0. Remaining still, not moving, stopped, any of those. I will take any of your answers there. Alright. Tricky one. Velocity is 0, but the sign changed. So let's try doing it. I am chugging along at 5 miles per hour. I come to a stop, and now I'm going negative 5 miles per hour. Therefore, what did I do? What did I do? I went 5 miles per hour. This is where velocity is 0, and then negative would be going backwards. So what did I do? Oh my God, really? No? Nothing? I went forward, stopped, and went backwards. Can someone describe to me what happened when I stopped? Wow! Really? That doesn't help. Aaliyah, I know you know the answer because I heard you say it. And right, I think I already heard you say it. Really? The rest of you? Nothing? I don't know. What would you say happened if I did this? And then I was like, oh, never mind. Really? But just because I did this and never physically turned my body, you couldn't tell that I turned around? Really? Really? It's amazing how your minds work. Yes, I turned around. Changed direction. It says it worked here. Changed. So let's talk about logic. If I'm asking you a question, the answer can't be what's written on the board. So you guys are telling me velocity is 0. I know that. I said that. I told you that as part of my hint. Velocity is 0. You can't go, velocity is 0. I already told you that, so that can't be the answer. So when velocity is 0, I'm stopped. But if before and after I changed from moving forward to moving backwards, then I'm changing position. Changing direction. This is a big and. You can't forget that this has 2 reasons. We'll talk about that in a second. All right, next guy. To answer of any of the questions involving direction of motion. We talked about positive, we talked about negative, we talked about 0. What do you think you need to know? First of all, what word keeps coming up in all of those? Velocity. So we know if I want to talk about moving, forward, backward, stopped, changing direction, I'm going to need to know velocity. If they give you position, what will you do to get velocity? Take a derivative. Remember I said 95% of the time you could probably just take a derivative always. If you have no idea what to do, just take a derivative. All right. And always make. What do you think you're going to make if I want to see positive, negative, 0? Where have you made things that do positive, negative, 0? Sign charts. The lack of connections in your brains. It is amazing. Guess where you just did those? Last night for homework, maybe? Maybe? Alright, leading up to this? Alright, steps. I'm not going to do all the steps of a sign chart, but I just want to remind you, if I want to make a sign chart, I take that function. What function are we talking about? Whose sign chart do I care about? Velocity. Says it right there. So I'm going to take the velocity, and what do? To start a sign chart, you set it equal to what? 0, and what else? And undefined. Particle motion, you won't see too many undefined, just because they want it to be realistic. So you won't see as many of those, but I still want you to always write it so that you don't forget about it. All right. Is there anything on this page that you have no idea what you're talking about? Anything you're lost on? All right, here we go. We're going to try a problem. We're going to have to walk through the problem a little faster to make sure we get done. All right, starting off. Also take out your calculators, because this is where I'm going to teach you guys how to use your calculators too. Or I shouldn't say teach. I should say I will remind you how to use your calculators. All right. So let's start off with, at what coordinate is the particle initially? So I'm going to read the beginning statement to you. The beginning says a particle is moving along the y-axis. So I'm on a coordinate axis, I'm moving along the y-axis. So to start off, we'll do this one easy by hand. Initially, when you see the word initially, what time are we talking about? Time equal to 0. All right, so y of 0 equals, that's an easy one, 1. What's the coordinate? Because it asked me for a coordinate. 0, 1. All right, awesome. This one we're going to end up using the calculator. It's a nice way for me to remind you how to use it. So let's start off with you putting into your calculators. You guys will take maybe less time than me. I'm not used to this guy yet. All right. And hopefully you're using X's. We're not going to graph it. So as you're typing in, notice I have parentheses here, and notice I don't have them here. It's because you don't actually need them. Your calculator knows to do exponents first. Your calculator also knows only to divide by the 3 and not by 3x cubed. So I think I have a little thing missing though, right? My plus. Because I was watching the other class put the function in their calculators and noticed they had like 50 million parentheses. I don't even know what the parentheses were doing. I think they were just there to make it look pretty. But you actually don't need any, surprisingly. Okay? So I put one set there just to show you, but I did one without to show you you don't really need them. All right, go to your home screen. Let's see if any of you remember how to do it. I want you to find y of, what are we doing? Y of 3. So y of 3 after 3 seconds. Anyone remember how to do it? If you do, can you try and yell out the steps? Anyone? 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 Math is incorrect. You're like, oh, she sounds like she's going to take my answer. Math is incorrect. Anyone have a button press? I'll give you a hint. It matches what you wrote. Your calculators know how to do function notation. Yes, I have showed this to you before. And yes, at the time I showed it to you, I said you need to do this and you need to be able to do it on your own. And as we see now, I should have given you a quiz on it. Bars is correct. Move over to y bars because you're using the y variable function. And you're going to pick which one you use. I used y1, so I'm going to pick y1. Then, function notation says use parentheses to put in your input. And your calculator will spit out the y value. I'm going to show you through the process of this problem why this way beats you typing it in. Okay? So keep that into y1. So this is 0.25, which is 1/4. And the coordinate would be 3, 1/4. And then I say, bah, wrong. Why would it be wrong? Why would she be so dramatic and mean? I'm going to give you a hint, because everyone gets it wrong. Everyone says 3, 1/4. It's logical. 3's here, 1/4 is here. That's totally logical. Go back to the beginning statement. Where am I moving? Along the y-axis. So, at time equal to 0, I was at 1. At time equal to 3, I was at 1/4. That makes sense now why it's not 3, 1/4, that they want to know a coordinate, and they're telling you they're moving along the y-axis. Does that make sense? So what's the actual coordinate? 0, 1/4, and the reason why? This is not time. What is it? It's the x-coordinate. I do movement along the x-axis, I do movement along the y-axis, I do movement along the line y equal to 2, x equal to -3, all of those just to kind of play around with the coordinates, okay? All right, moving on to this guy. All right, so now it says what's the average velocity during the first 2 seconds? What's the velocity at 2 seconds? Out of the two questions, which one do I use a derivative for? C, because it doesn't say the word average. That means this one is derivative. So let's write in the derivative. So v of t would be, bring down the 4 and you get t cubed. Bring down the 3 and you get -5t squared. Bring down the 2 and you get 8. And bring down the 4 and 1's 0. V of 2. I'm going to show you how to use your calculator for that. This you were supposed to practice on your own. I'll give you like 10 seconds to get started. You already have this in there. I don't want to see this in the calculator at all. The velocity, you shouldn't have to put it in. So given the position function in your y1, you should be able to find the derivative at 2. I see, right, he's like all excited. He's like, I know this. Right, what's the first button that you thought you might need to press? Math is a good start. Math, you remembered that. Math was a good start. Where do you go after that? So, math is here, and I heard the number. It's 8. My screen is a little bit bigger, so it shows it. 8. This is the new calculators. I'll show you the old ones. Down here, because we're still using the same notation, it'd be d over dx. So x would go down there. This would be where I put the function. Where's the function hiding? It's hiding in y1, so vars, move over. Function, y1. And then where do I want to take the derivative? I want to take it at 2. Does everyone understand? I did not use this in the calculator at all. I haven't touched it, okay? There you go, press enter. You get this crazy looking answer. How many decimal places do you have to be correct up to? Did we just say 6? Did I hear 6? Oh, okay, 3. 3. So up to 3 decimal places, what would that look like? Well, the point would go backwards 1, 2, 3, 4, 5, 6, 7. What's the answer? 0. If you substitute 2 into the v of t function, you can do that. It's 0. It'll be 0. All right. Average velocity. What's the formula for an average velocity? What function do I use? S. S sub 2 minus S sub first 2 seconds. What's the other number? 0. Good. All over 2 minus 0. So, you can do that in the calculator too, right? Parentheses. Actually, let's just do the top. Vars, y vars, enter, function 2, minus, vars, move over, y vars, function 0. Find that answer first. And then what do I do to that answer? Divided by 2. Enter. -0.666666666. What is that the same as? -2/3, I believe. Hopefully I did that right. Hopefully I typed everything in correctly. Verify if I get that wrong. All right, so that's the easier questions. Now we're going to do what we call analyzing a function. Have I lost anyone here? being able to use your formulas. You should be able to do it without the calculator. You should be able to do it with the calculator. If I give you the calculator, it means I want you to use it. It means you will run out of time if you don't. That's what that means. Tiffany? Which kind do you have? Do you have n deriv actually show up, or do you have d over? So n deriv, you should be using y1, comma, x, comma, 2. Sorry, I forgot to put that down. For those of you that have the old calculators, that still write the word n deriv, this is how you would put it in. I'm sorry about that. It's the same 3 things that we put into the other calculator. All right. No problem. All right, this guy. So, here are the questions, and you got to remember these types of questions. If I ask you about particle motion, moving forward, moving backwards, stopped, changing direction, these are called particle motion problems. Every single one of them, you should be analyzing what function. What function is important for these? The velocity. And let's go through the reasons first. If I want to know if a particle is moving forward, what do I need? What do I need to know? Well, considering we just wrote the fact that this was velocity, I would say velocity would be the start of that answer. And what type of velocity? Positive. But look at the way I write it. I'm not going to write the words velocity as positive. You're going to learn to write things faster. That's the same exact thing as saying the words velocity is positive. Why would I teach you that? Because you're going to be writing in a timed fashion, so you want to write fast. Backwards. Now that you see all that, what do we know for backwards? Less than 0. Because what kind of velocity gives you going backwards? What kind of velocity is less than 0? Negative. When do you know you're stopped? Velocity is 0. How do we know we're changing directions? 2 reasons. First reason, velocity is 0. Second reason, and what? Isaac, I can't hear you. I know what you're trying to say. You are trying to say the right thing. There's a quicker way to say it, so you don't have to say the positive, negative, all of that. What was the other piece? Sign switch. Changing signs. You do realize we just took notes on this like 2 seconds ago, right? And all you had to do was flip back a page and it would be sitting there right there, right? Right? I'm just making sure we understand that. Okay, so this guy, what do we need to do? What do I need to do to answer all these questions now? I need a sign chart. Therefore, you guys already have the velocity written. I'm going to rewrite it. T cubed minus 5t squared plus 8t minus 4. That's not factorable. Well, sorry, I shouldn't say it that way. It is factorable. I don't expect you to factor it. How would I find what I need to know? Well, first of all, let's go back to, if I use v of t and make v of t's sign chart, I take v of t and set it equal to what? 0 and undefined. Can this ever be undefined? No. So I want it equal to 0. I gave you calculators. What would you look for to make this equal to 0? What does that look like? I heard you say it. X-intercepts. So take your calculators. There's already, it's in your calculator. No, this one isn't, sorry. There is a way to graph the derivative. I'm not going to deal with that today. Go ahead and put that into y2. Leave your y1 alone. Put it into y2. And I guess I should graph it also. See if I have enough time to graph it also. What is it? X caret 3 minus 5t squared. Oopsie, I hate this calculator. X cubed minus 5t squared plus 8t t minus 4. And then if you have no idea what the graph looks like, you can zoom 6 to start. You should be able to see it, hopefully, if I did it right. It takes a little longer. Alright, so I think in the other class they told me there was 1. Take a look at that. Is that a good graph? Can you see the x-intercept really well? I just realized the other class did not graph it well. So what do I want to do right there? Zoom in. That'll be the easiest way to do it. Press enter. This one's a little bit slower. Come on, calculator. Let's do our work. What are the zeros? Is it just 1 0? It's 1 and 2. Alright. So 1 and 2. So v of t. The bell's going to ring. I need to finish. So velocity is based off of time. Time cannot be negative. Is that a true statement? We all agree that we can't have negative time. So don't you dare give me negative time on your sign chart. I don't want to see it. You'll get confused and you'll give me a bunch of wrong answers down here. So we said it was at 1 and we said at 2. Can you guys please understand that if I'm giving you your calculator and your graph looks like this, you can't leave it like this. You have to zoom in right there to see, is there 1 0? Is there 2 zeros? Is there 3? Who knows? You need to do that, please. I'm going to quickly run you through your sign chart. So, if this is the graph you graphed, and this is the sign chart I won, and they are the same, using your graph on your calculator, what would you look at? Y values. So, using the calculator screen, that's this guy. Sorry, I'm going to try to get you out of here very quickly. Not the best graph. Let me see if I can zoom in a little bit. Let's try one more time. There we go. There we go. Much better. Alright, so take a look. I'm going to just sneak this right in the middle right here. Alright, so y values. What are my signs then? I know these are zeros. What's my sign from 0 to 1? Negative because the y values are below. 1 to 2, that little hump, positive, right? And then at the end, positive. Okay? If you're not sure, you can't guarantee it, you got to look a little closer. Zoom in some more. I know the answer, so I know that this is correct, so this is okay for us, okay? Now, can I answer the questions? Well, yeah. When am I moving forward? From 1, look what I did, open circle, sorry, open because velocity is 0 at 1, so I don't use it. I do usually 1 to 2, skip 2, and then do 2 to infinity. That's because at 2 you're not moving. Your textbook will do this though. Your textbook will do this. Okay? You'll never see me do that. I'll always answer this way. This is also correct. They're both correct. You won't see me write it this way. I'm consistent. I choose one way, I stick to it. This is the way I stick. Negative or backwards, I'm using 0 because I bet you at 0 the velocity is actually a negative number, so I get to use it until 1. I'm stopped in 2 places, 1 and 2, but I only change direction once. Where do I change direction? At 1. I'm going to give you one last bit of notes so that you don't have to watch a video when you leave. That's going to be acceleration. Just making sure you know acceleration is the derivative of velocity. A lot of you guys already know that. It's the second derivative of position. We can write it these 2 ways. And then your book, at some point, will start talking about a jerk. That's actually the first derivative of acceleration. It's not on the AP, but your book talks about the jerk. That's where it comes from. Thank you for staying with me.